I am going to the formula sheet section, and it's located on Blackboard and under the all exam formula sheet. The very last page deals with conics. And as far as the ellipse is concerned, here are the formulas for the ellipse. Okay, so we're going to look at these formulas for ellipses not centered at the origin, and then we're going to take a look at ellipses that are not centered at the origin. All right, so the first thing we're going to do is talk about the two types of ellipses. For an ellipse, you have what's called a major axis and a minor axis. On the major axis of an ellipse, you can find the vertices and you can find the foci. Right? Foci is plural for focus. In the parabola, we only have one focus, but in the ellipse, we have foci. Okay, we have two focus points. First, we're going to take a look, and I'm just going to sketch these out instead of just looking at these formula sheets. I'm going to sketch out, first, this is for an ellipse. And I'm going to make this a tad darker. All right, so the first set of formulas we're going to take a look at are the ellipse with a horizontal axis centered at the origin. Okay. All right, so if you have an ellipse with the horizontal axis, so what that means is my major axis, in this case, is my horizontal axis, and this is just the arbitrary shape. All right, so if you have an ellipse that's centered about the origin with a horizontal axis, it's going to look like an egg shape or an oval shape on its side. Okay. If you are dealing with an ellipse with a horizontal axis, here is the model form. X squared over a squared plus y squared over b squared is equal to 1. So that's the model form for an ellipse with the horizontal axis centered at the origin. Okay. Now, one thing about the ellipses, in the denominator, we have a squared and a b squared. A has to always be greater than b. So if you look at your denominators, and whichever number is the largest, that's going to be considered to be a. So in this case, if you notice the largest number is underneath the x variable, you can kind of think of that x variable as representing the x-axis. Okay, so this is a ellipse with the horizontal axis centered at the origin. Okay, so for any ellipse, a has to be greater than b. Now along this horizontal axis or the major axis, we can find the vertices. Some are going to call this V and V prime. The coordinates for the vertices are plus or minus a comma 0. So here again, if we look at our denominators, the largest denominator is going to be a squared. We take the square root of that, and that will give us a. So the vertices are located at plus or minus a comma 0. Also along the major axis, we have the foci points. The foci points are also located along the major axis. The coordinates for the foci are plus or minus c, comma 0. Right? Those are the items you can find along your major axis. On our minor axis, okay, well, let me just label the foci. I'm going to call this F, and I'm going to call that F prime, okay, just to show where these things are located. All right, along the minor axis, we can find the minor axis endpoints. Okay. So for our minor axis endpoints, they're going to take the form 0, comma, plus or minus b. And lastly, okay, we haven't taught anything about C. C has its own formula. C is going to equal to the square root of a squared minus b squared. All right, so these are, I can't shrink this down any, but these are all of the formulas that are related to an ellipse with a horizontal axis. All right, now we're going to look at an ellipse with a vertical axis. All right, so this is for an ellipse with a vertical axis centered at the origin. All right, so I'm going to just sketch out another x and y axis. So if we have an ellipse with a vertical axis, it's sort of like a egg shape if you stand it up, or an oval shape standing upright. So that ellipse would look something like this. Now, since this has a vertical major axis along, well, first let's talk about the model form. All right, so for the model form for an ellipse with a vertical axis, it's going to take this form: x squared over b squared plus y squared over a squared is equal to 1. So we still have to keep in mind that a must be greater than b. So you notice in this setup, the largest denominator is underneath the y variable, and you can liken that y variable to the y-axis. So along that major axis, we can find the vertices, b and b prime. So the vertices are located at the point 0, comma, plus or minus a. The foci are also located along the major axis. So the foci have the coordinates plus or minus c, comma, 0. Excuse me. 0 plus or minus c. They're located on the y-axis. On the minor axis, right, we can find those minor axis endpoints, and they're going to have the coordinates plus or minus b, comma, 0. So that's b and b prime, and I forgot to label these over here. And then we have our formula for C. C is equal to the square root of a squared minus b squared. Right. So these are just the basic formulas for ellipses that are centered at the origin. All right, now we're going to take a look at just sketching one out by hand. Okay, so I'm actually going to pull this from our Blackboard course shell for class lectures. I'm sorry, for lecture notes. This is actually section 6.2 is where I'm pulling this from. So in the lecture notes from 6.2, we can find the ellipse. Okay, this is just a little bit more information which I just went through. An ellipse is a set of points in a plane whose sum of all distances from two fixed points is constant. Each fixed point is called a foci. So here's what makes an ellipse an ellipse. It says it's a set of all points in a plane whose sum from two fixed points is constant. So here's what that means. The fixed point is called a focus. So here's one of my fixed points, and this is the other fixed points. So that means if I were to take this point and this point, I could find the distance using a ruler. And then I can take my other focus point to the same point on the line, and I can find that distance. And I add those two distances up. Those two distances is the same no matter where this point is on this ellipse. So that means if the point on my ellipse was here, if I were to measure the distance from my focus point to the point on a curve, measure the distance from the other focus point to the point on my curve, and if I were to add those two things together, I'm going to get the exact same value as I did before, right, using a different point on the ellipse. So that's what makes an ellipse an ellipse. Another fact about an ellipse, there are the orbits of the planets, but for some strange reason, the moon has a circular orbit. I believe it's the only planet in the solar system with a circular orbit instead of an elliptical orbit. All right, so we talked about the equation for the ellipse, and these are just equations for ellipses at the origin. And then here's just an example on the slide that says the graph. Okay, so I'm going to do a rough sketch. It says graph 4x squared plus 9y squared equal to 36. 4x squared and I must be running out of space. Graph 4x squared plus 9y squared, bless you, is equal to 36. Okay. First thing I do is put it in standard form. So standard form just simply means you must set your equation equal to 1. So in order to set this equation equal to 1, I'm going to divide everything by 36. So put in standard form. So I'm going to divide everything by 36. And the reason why I'm choosing 36 is because if we look at the right-hand side of our equation, anything over itself is 1. So I put 36 over 36. Whatever you do to one side, you have to do the same thing to the other. So I'm dividing everything by 36. All right. So now I'm going to just reduce everything down. So 4 divided by 36 gives us 1 over 9. So I can write that as x squared over 9 plus 9 over 36 reduces down to 1/4, right? So I can write that as y squared over 4 is equal to 1. All right. So now in order to graph it, I'm going to look at my model form. I'm going to pull out the vertices, the minor axis, And from that point, I'm just going to draw the ellipse. So the second thing we're going to do is sketch. So the vertices. So how do I know which model form to use? Right? Is it in horizontal axis or a vertical axis? The key thing is look for the largest denominator. In this particular problem, the largest denominator is 9, so this is going to be an ellipse with a horizontal axis. Now, this is what they call standard form. I'm just used to writing it out like this. Or you may see it like this, x squared over 3 squared. I think that's how they want you to answer when they say put it in standard form. Plus y squared over 2 squared is equal to 1. I don't know about this. I hadn't actually entered these problems into the homework. It says I don't know if they're going to accept x squared over 9 plus y squared over 4 equal to 1, or if they want it written out like this. But I'm thinking it with squares. Okay. All right, so now that I know that I have a horizontal axis, I'm going to just look at my formulas. The vertices are plus or minus a comma 0. Oops. Well, what is a? Well, a is going to be 3, right? So that means if a squared is 36, excuse me, if a squared is 9, then a is going to be 3. So my vertices are located at plus or minus 3 comma 0. To find my minor axis points, the formula is 0 plus or minus b. So if I take a look at my formula, which is 0 plus or minus b, I notice that b should be 2, right? Because if b squared is 4, we take the square root of both sides, b is going to be 2. So my minor axis points are located at 0, comma, plus or minus 2. So that's what I'm going to graph. This thing will not let me slide it over. All right, so just a little quick x and y axis. My vertices are plus or minus 3, comma 0. So I'm going to go over 3 places to the right. Since my coordinate is 0, I'm going to remain on this point. My other vertex is negative 3, comma 0. My minor axis point is 0 plus or minus 2. So since my x coordinate is 0, I don't move to the left, I don't move to the right. My y coordinate is positive 2, I'm going to go up 2. And then I'm going to go down 2. So my ellipse, even though it's crazy looking, it should look something like that. Okay, with a horizontal axis. Now let's take a look at XYZ homework and graphing. It took me a minute to figure out how to graph these things using the system. Okay, you can do it by hand pretty easily, but using the computer, I kind of figured out the little trick to it. Okay, so we look at, I think it was problem 4, 5, and 6. We'll do 4, 5, and 6. All right. So it says x squared over graph x squared over 25 plus y squared over 1 equal to 0. So first off, does this thing have a horizontal major axis or a vertical? Well, I'm going to look for my largest denominator. It's underneath the x variable, so I can liken that x variable to the x-axis. So it should have a horizontal x-axis. Now that's going to be important to know because once we start the graph, there's a certain pattern you must follow. Okay? So if this is a square, then a is going to equal to what? 5, right? If this is b squared, then b is going to equal to 1, right? So now this is how I'm going to plot this. I'm going to choose the elliptical tool. You have to start at the center, the origin, right? Because this thing is centered at the origin. Then I'm going to move along my major axis, which in this case is horizontal. So I'm going to go 5 units to the right. 1, 2, 3, 4, 5. It doesn't really matter if you go to the right or left, but if you look really close, you'll see that it gives you the major axis. And since my value for B is 1, I'm simply going to go up 1 unit, and I'm going to lock that in. And if I hit submitted, this is the graph. So it's real particular on your movements on this graph. Any questions about number 4? Start at the center, move to the left or right, and then move up or down. For problem number 5, same deal. X squared divided by 1 plus y squared over 9 is equal to 1. And we're asked to graph. So the first thing I'm going to do is look at my denominators and determine which is the largest denominator. So in my particular problem number 5, the largest denominator is 9, which is underneath, which is underneath the y variable. So we can liken that to the y-axis. So this particular problem has a vertical major axis. So now here's how I'm going to graph it. I'm going to choose the elliptical tool. I'm going to plot my point in the center. This time, since my major axis is vertical, I'm going to go up 3 units, right, because the square root of 9 is 3. 1, 2, 3. I'm going to go 1 unit to the right, right, because B, it should be 1, so I'm going 1 place to the right. I'm going to click my mouse to set that in, and that is the graph. Any questions about number 5? Now, both problems number 4 and number 5 were centered at the origin. Okay, and they're centered at the origin because we didn't have any constants attached to the x or the y variable. However, for problem number 6, this is an ellipse that's not centered at the origin. And I need to write the problem down. You just write this down. X minus 2 quantity squared over 16 plus. All right, so we take a look at number 6. X minus 2 quantity squared over 16 plus y minus 1 quantity squared over 9 is equal to 1. The first thing I have to do here is find the center. Okay. In the problems before, the center was the origin. So just remember that the center is written in the form h comma k. H follows the x variable, and k follows the y variable. And remember that your sign changes, just like with the parabola. So if I pull out my value for h, it's going to be positive 2, right? Because h follows the x variable, and you must change the sign. K follows the Y variable, and we change the sign. So we have the center at 2, 1. Right. So this time, instead of plotting the first point at the origin, we're going to plot the first point at its center, 2, 1. All right. So I'm going to go over 2 to the right and up 1. And then we plotted basically the same way as we plotted the other two, just the center straight from the origin. So I plotted my center at 2, 1. Since my largest denominator is underneath the x variable, this thing is going to have a horizontal axis. So from the center, I'm going to move 4 units to the left or right, but I want to choose to move to the right. 1, 2, 3, 4. And the reason why I'm using 4 instead of 16, because 16 is a square, but in our formula we only want a. So I go over 4 places to the right, and then I'm going to go up 3, 1. Oh, let me choose the right tool. Let me choose the elliptical tool. I was on a circle. So this is an ellipse. I'm going to replot the center at 2, 1. I'm going to go 4 places to the right. I'm going to go up 3 units. And that should be our graph. All right, so any questions about number 6? Okay. All right, so that's just for the graphs. So no graphs by hand, just knowing how to put them into the program and graph. All right, now we're going to take a look at finding the major axis points, end points, foci points, and to rewrite an equation in standard form. So let's take a look at problem number 2. It says write the equation of the ellipse in standard form and identify the endpoints of the major and minor axes as well as the foci. All right, so first thing it asks us to do is write the equation in standard form. So the standard form of this would simply be to square out the denominators. So this is, I believe, what they want. X squared over 4 squared plus y squared over 2 squared is equal to 1. So that's our equation. Next, we're asked to find the endpoints of the major axis. So once I put it in standard form, next I'm going to fit to a model form. So one was right on standard form. The second thing we have to do is find the model form. Okay, so when I say model form, does this thing have a horizontal or a vertical major axis? Well, in order to determine that, we look at the denominators. 16 is the biggest denominator, is underneath the x variable. So this thing would have a horizontal major axis. So I'm just going to use these formulas. So the correct model form is horizontal axis formulas. So in order to find the vertices And they don't necessarily call them the vertices. In here, they call them the endpoints of the major axis, which are also known as the vertices. So if you look back at those formulas for an ellipse with the horizontal axis, the vertices are located at plus or minus a comma 0. So a is going to be 4, right? So my vertices are located at negative 4 comma 0 and positive 4 comma 0. Next, we're asked to find the endpoints of the minor axis. And if you look back at those formulas, they take on the form 0 comma plus or minus b. And since we wrote the equation in standard form, we can see that b should be 2 because the square root of 4 is 2. So I'm going to write this out as 0 comma negative 2 and 0 comma positive 2. Then it says the foci are located where? So to find the formulas for the foci, remember we have to use c is equal to the square root of a squared minus b squared. So the next thing I'm going to do is I'm going to find c, and then we can write out our foci points. So c is equal to the square root of a squared minus b squared. A squared is 16, right? Because 4 squared is 16. Minus 4, so c is equal to the square root of 12. Now, I didn't actually put the answers in. I don't know if it's going to accept the square root of 12. But you can simplify it. I know that XYZ is not really a stickler for like simplifying fractions and simplifying radicals, but this is how you would simplify this. So there's something called the product rule for radicals, and it says that the square root, the nth root of a times the nth root of b is equal to the nth root of a times b. So that means I can simplify the square root of 12. Now this formula works both ways. Like if I were to find the multiples of 12, right? The multiples of 12 are 1, 2, 6, and 12. No. 1, 2, 3, 4, 6, and 12, right? Because 1 times 12 is 12, 2 times 6, 3 times 4. I want to pick two numbers that I can multiply to get 12, but I want one of the numbers, if possible, to be a perfect square root. If I look at all my factors for 12, the only square root is 4. So that means I can rewrite the square root of 12 as the square root of 4 times the square root of 3. Right. The square root of 4 is perfectly 2, so you can rewrite the square root of 12 as 2 times the square root of 3. Just to show on the calculator that these two numbers are exactly the same, they're just written in a different form. I'm going to just attach a decimal value. So the square root of 12 is 3.46. 2 times the square root of 3 should be the exact same value, just written in a different form. So they may accept the square root of 12, but they may not. I did look at the answer though, and they had it written out as 2 square root of 3. All right, so if C is 2 times the square root of 3, then our foci points are plus or minus c comma 0. Right, those are the coordinates for a foci for an ellipse with a horizontal axis. So the foci would be located at -2 square root of 3 comma 0 and positive 2 square root of 3 comma 0. And I'm going to bring this back over. All right, so -2 square root of 3 comma 0 and 2 square root of 3 comma 0. Any questions about number 2? I mean, pretty straightforward. Once you locate the model form, take a couple of square roots, maybe find C if you have to find a foci. All right, here is problem number 3. Okay, and this problem number 3 is not centered at the origin, so we're going to use the formulas for an ellipse not centered at the origin. Okay, so basically what I did is I just copied the problems from the homework, and then these are the formulas that are given in the problem. Now there's one that said major axis, and just for time, I kind of cut that out. I didn't paste that part in. But there is on that same thing, there's a formula for vertical axis, for horizontal axis. All right, so it says write the equation of the ellipse in standard form and identify the vertices, the endpoints of the minor axis, and the foci. So first off, writing this in standard form, I'm basically just going to square root the denominator. Squared. So this is x plus 3 quantity squared over 2 squared plus y minus 3 quantity squared over 16 over 4 squared is equal to 1. So this is our standard form. Now we have to find the vertices. So if you look at your equation, you have to find a model form In order to find a model form, we look for the largest denominator, which is 16. It's underneath the y variable, so this thing has a vertical axis. So I just took the liberty to cut and paste these formulas. So I'm just going to slide that down. All right. What is the center? Well, the center is not at the origin because we have constants attached to x and y. So remember that h follows x with a sign change and k follows y with a sign change. So my center should be located at -3, +3. So my center is -3, +3. So h is going to be -3. K is going to be +3. Next, let's find the major vertices. So now looking at this formula, it's h comma k plus a and then h comma k minus a. We've already pulled out h and k, right? H is -3. K is +3. What is a? Well, to find A, I look at my largest denominator, which was 16. You square 16, you get 4. So A is equal to 4. I'm also going to find B. So in order to find B, we look at our smallest denominator, which is 4. The square root of 4 is 2. So B is 2. And I'm also going to find C. So in order to find C, we're going to use that formula. C is equal to the square root of A squared minus B squared. A squared is 16 minus B squared, which is 4. So C is equal to the square root of 12. And we simplified that in the last problem, so that should be 2 times the square root of 3. Right, that is C. Right, 2 times the square root of 3. So we pulled out the center, which is H and K. We found A, B, and C. Alcohol, beer, and cigarettes. One person thing. All right. All right, so now let's find the major vertices. They take on the form H, comma, K plus A. So H, we found that as -3. K is +3. And A is 4. So that's 3 plus 4, comma, H, comma, K minus A. So H is -3. K is 3. And then it's a minus because of our formula. And then A is 4. So once we simplify, we should have the vertices of -3, comma 7, and -3, comma -1. And those are our vertices. We can find our minor axes in the same manner. Just follow the formula. So the minor axis formulas are H plus B, comma K. So we found that H is -3. Comma, H plus B, I'm sorry. So that's -3 plus B, which is 2. Comma K, which is 3. And then we have H minus B, so that's -3 minus 2, comma K, which is 3. So now we simplify. -3 plus 1, -3 plus 2 is -1, comma 3. -3 minus 2 is -5, comma 3. So those are our minor axis points. Now we're going to find the foci. So it has the coordinates H, comma K plus C. So that's -3, comma 3 plus 2 square root of 3. because we found C, right, in an earlier calculation is 2 times the square root of 3, comma, -3, comma, 3 minus 2 square root of 3. And that's your foci, basically, because you can't add 2 and plus 2 square root of 3. All right, you can only add like radicals. If you think back to algebra, right, you can only add like radicals. So since 3 is not a radical, it just has to stand alone, but it's still being added to the 2 square root of 3. All right, any questions about number 3? All right, so that was not at the origin. All right, now here is the last one. It's number 8. So there's actually 2 problems on here like number 8. And in number 8, they want us to determine the given equation in standard form. But notice they give us an equation that's not in standard form. So what we must do is we must put it in standard form, and we have to use something called completing the square. Okay, and this goes back to college algebra. So like I said, this last module is throw the trig stuff out the windows. No sine, cosine, anything. Basic algebra. All right. So the first thing we want to do, I want to group my like variables and isolate the constant term. So remember, a constant is just a number. There's no variables or anything attached. So when I say isolated, that means I want to put my constant on the other side of my equation, and everything else is going to stay on one side. Right? And along with that, I'm going to group my like variables. So here's what I mean. I'm going to take my x's, 25x squared plus 100x. Okay, I'm just going to kind of stick them together. Sometimes in these equations, they may be like jumbled around. Plus 16y squared minus 32y is equal to 284. When you complete the square, you got to have a certain form. You must have the squared term and the first degree term. So what's sort of implied in this is that the coefficient of your squared term must be 1. The coefficient of the squared term must be 1. Once you have the right form, you have your squared term and your first degree term only, then you can complete the square. So I'm kind of writing this out in an abstract kind of way, but you have to take half of the middle term and you have to square it. I'll just show you how it is. All right. So once you have the right form, the coefficient is 1. You want to take half of the coefficient of the middle term and square it. Now, for this example, the coefficient is just 1, but that's not always going to be true. So now if we go back to our problem, we have two variables, an x variable and a y variable. So we're going to have to complete the square twice. So if I look at my x variables, do I have the right form to complete the square? Well, it's like in order for me to complete the square, the coefficient of this first squared term has to be what? A 1. All right, so what I'm going to do is for my first terms, or for my x term, I'm just going to separate them out with a set of parentheses. I'm going to factor out 25. And if I factor out 25 from this first term, I'm going to be left with x squared plus 4, right? Because 25 times x squared is 25x squared. 25 times 4x is 100x, right? Plus, and I'm going to put a blank. And I'm going to explain that in a second. I'm going to bring this plus down right here. And I'm going to look at my y variables. Is the y variable in the correct form to complete the square? Well, we have the second degree term and we have the first degree term, but the coefficient of the squared term is not 1, it's 16. So I'm going to factor out 16. So if I factor out 16, on the inside of my parentheses, I should have y squared, because 16 times y squared is 16y squared, minus 2, because 16, or excuse me, I'm going to have minus 2y, because 16 times negative 2y is negative 32y. So I'm going to put a plus and a blank. And on the other side, I'm going to put 284, and I'm going to put plus blank plus blank. So why am I writing these blanks? Whenever you complete the square, you force what are called perfect square trinomials, which means you can easily factor them down. But from algebra, the probabilities of equality tell us whatever we add to one side, we got to add the same thing to the other side. So now how do we fill in these blanks? Well, we fill in these blanks by completing the square. Since we have the squared term in the first degree term and the coefficient of the squared term is 1, I'm going to take half the coefficient of my middle term. So coefficient for my middle term is 4. I'm going to divide that by 2. And then I'm going to square it. And that's what I put here. So half of 4 is 2. And 2 squared is what? 4. So I took half the coefficient of the middle term and I squared it. I'm going to do the same thing for the y variables. If I take half of negative 2, that's going to give me a negative 1, right? But if you square negative 1, you get what? Positive 1. All right, so any questions about where the 4 and the 1 came in? All right, now here's where the properties of equality come in. Whatever you do to one side, you have to do the exact same thing to the other side. So if I go back, 25 times x squared is 25x squared. 25 times 4x is 100x. 25 times 4 is what? 100. So I added 100 to the left-hand side. I got to add 100 to the right-hand side. So notice I didn't put 4 because factored out of 25. So that's like 100 in disguise. If I look at my y variable, 16 times y squared is 16y squared. We started with that. 16 times negative 2y is negative 32y. We started with that. But 16 times 1 is 16. We did not start with the 16. We added that to the right-hand side. So we have to add it to the left-hand side. Okay, any questions about this step? All right, so I kind of alluded earlier that when you complete the square, you form what are called perfect square trinomials, which means this thing can be factored. So I'm going to bring down my 25. Okay, so here's the trick to this. I can rewrite x squared plus 4x plus 4 as x plus 2 quantity square. Okay, I'm going to just show that. If I have x plus 2 quantity square, that's x plus 2 times itself, right? So I don't like square root of x and square root of 2. I got to multiply x plus 2 times itself twice. And then if I just use that full method, x times x is x squared. X times 2 is 2x. 2 times x is another 2x. And then for my last terms, I get 4. So this would give me x squared plus 4x plus 4. And sorry for writing that down at the bottom. So that proves that x plus 2 quantity squared is x squared plus 4x plus 4. So that means when you complete the square, you're going to force these perfect square trinomials. Okay, now here is this is the little trick to determine which number you put. So like earlier, for when we talked about the x variable, right, we took 4 and we squared that, right? I mean, we took 4 and we divided it by 2. So that gives us 2. Come on. That's my magic number that I put here. And it's plus because of my sign, that sign of that middle term. So like if I do the same thing for the second term, how would I factor that down? Well, what's negative 2 cut in half?
1 minus 1.
That's going to be negative 1, right? That is the number I put here. I'm trying to go back and forth on these colors. Is everybody okay with that? That's equal to 284 plus 100 plus 16. I believe that's 400, right? Yeah, 284 plus 16 is 300 plus 100 is 400. So now how would I put it in standard form? Well, the ellipse has to be set equal to 1, right? So I can make this right-hand side equal to 1 by dividing by 400. So whatever I do to one side, I do the same thing to the other side. So I'm going to divide everything by 400. So now I am going to simplify. So 25 divided by 400. I can like divide both of those by 25. Or I think calculator reduce it. If I put in 25 divided by 400, if I hit equal, or it gives me a decimal, but I can go into math. I can choose that first option, and it gives me 1 over 16. So I can rewrite that first term as x plus 2 quantity squared divided by 16. Right, because there's an understood 1 up here in the numerator. Plus 16 divided by 400. We can also reduce that down to 1 over 25. So I can write the second term as y minus 1 quantity squared over 25. And on the right-hand side, 400 over 400 is 1. And then to put it in the standard form as they like, I'm just going to square root the denominator. So I should have x plus 2 quantity squared over 4 squared plus y minus 1 quantity squared over 5 squared is equal to 1. So we had to complete the square in order to put that equation in standard form. Is everyone okay, or would you like to see another one?
I have one more question.
Uh-huh.
Can you scroll back up a bit?
I used to shrink this stuff down right here.
Yeah, so x squared plus 4x minus 4 and y squared minus 2y plus 1. How'd you know it was minus 4?
Talking about this right here?
Yes.
Oh, that's a plus.
Oh,
I'm sorry. Whenever you square a number, it's always going to come back positive. I apologize for that. That should be put. Both of those blanks should carry a positive sign. So is everybody okay, or should I do another one? Another one. I'll do the last one. I don't know how that was. This one, give me a second. Let me just copy this over. It was number 9. Let's see. All right, this is the last one, number 9. All right, so this is number 9. We're going to do this the same way, okay? So we're going to regroup. We're going to group our like variables on the left-hand side, and then we're going to push the constant to the other side. So this is 4x squared minus 16x plus 25y squared minus 150y is equal to negative 141. So I just regrouped my like variables, and I isolate it for the constant. So if I look within my x variable, I don't have the right form to complete the square because the coefficient of my squared term is not 1. So in order to force it to be a 1, I'm going to factor out a 4. So once I factor out a 4, on the inside of my parentheses, I'm left with x squared minus 4x plus blank. If I look at my y variable, I have my squared term and my first degree term, but the coefficient of my squared term is not 1. I'm going to force it to a 1 by factoring out a 25. So on the inside of the parentheses, I'm left with y squared minus 6 plus blank. That's equal to negative 141 plus blank plus blank. All right, so we regrouped like variables, isolated a constant. We factored out to get the right form. So now I'm going to complete the square for my x variable. So to complete the square, we take half of the coefficient of our middle term. So the coefficient of my middle term is negative 4. I'm going to divide that by 2, and I'm going to square it. So I get 4, right? Because negative 4 half is negative 2. Negative 2 squared is positive 4. For my y variable, same deal. I am going to take half the coefficient of the middle term and square it. So I get 9. So if I go back to my problem, 4 times x squared is 4x squared. I started with that. 4 times negative 4x is negative 16x. But 4 times 4 is 16. I did not start with that. So I added it to the left-hand side. So I'm adding it to my right-hand side. 25 times y squared is 25y squared. 25 times negative 6 is 150. And then 25 times 9, right? I added that to my left-hand side. I also have to add to my right-hand side. So 25 times 9 is 225, so I must add 225 to my right-hand side. So now if I complete my square, or simplify the completed square, this should be x minus 2 quantity square, because I'm just simply taking negative 4 divided by 2, which is negative 2, and that's my magic number. If I factor the second term, that should be y minus 3 quantity square. Right, because if I look at that, negative 6 divided by 2 is negative 3. That's my magic number. That's equal to 225 plus 16 minus 141, that should give us 100.